Okay, Spartan time. Let's take a quick look at these. Um, so these are similar to what you're going to see in class today, and also what you're going to be dealing with later on the quiz on the second part of class today. So it behooves us to kind of tear this problem apart to make sure we know what everything means, and then how we can actually answer this question really well. So let's get to her. So the first thing we have to do is make sure we understand this terminology. We have x min, x max, x increment, x y min, y max, y increment. So when you think about x min and you want to put some words to it, this literally means you need to find the smallest x number that you have to graph. Okay. Or I should actually say they have to show on your graph. Okay. It's very easy to lose sight of the fact that what we're actually doing in this exercise is picking numbers that we're going to put on our graph. So the graph that you can't see, of course, but the graph that we could make at any time. So we're trying to find the smallest number on the x-axis, on this guy right here, that we actually have to show in order to be able to show all our numbers in our table. So the exercise is not going to be simply looking at the smallest and biggest number in your table necessarily. It's going to be looking at the smallest and biggest number you have to put on your graph that we're not actually asking to make in this step, but we could in say like the next step. In that same kind of thinking, if we're talking about the x max, we're looking for the biggest number that you have to show on your graph. Which brings us to x increment, which is just a really fancy way of saying what are you going to count by. Okay. So I'm not going to do the highlighting on the other side, but you can kind of see y min, y max, y increment. That means what's going to be the biggest number and smallest number that I have to show on my graph to cover all the numbers in my table. And then increment is going to be, well, what am I going to count those by? So let's talk about how we can make those decisions really, really well. And it really has to do with a careful analysis of your table. So y min, I'm sorry, let's go to x. So let's go x min, x max. So the first step in this process is probably just looking at your table, looking at the x column, and asking yourself, well, what's the biggest and smallest number that we actually have to look at in our table? So I can highlight 5 to be the smallest, 35 to be the biggest. So here's where we have to kind of mix a couple different things together. The shortest possible answer, the quickest possible answer is going to be then I have to graph from 5 to 35. Which should be okay, and that's an acceptable answer, but we also want to kind of think forward to, say, if I wanted to take this table and put it onto a graph, and sometimes it's appropriate to kind of go just beyond those ranges. So -5 and 35 are totally fine, but if you think about the graph, if I have, if I want to cut my graph off at 5 and 35, so here I have my x-axis, and I want to put -5 on this end, and then 35 on this end, well, that means I'm going to actually probably have a value that's going to be like right there, or like right on the edge of the graph. Not the worst thing in the world, but sometimes it's standard to go just a little bit beyond. So kind of make sure you're playing with both those ideas. -5 and 35 are okay, but sometimes you want to bump just a little bit farther when you're actually making your graph. Now, in terms of what we're going to count by on our x, we have to, again, take a couple things in consideration. One, I would definitely look at my table. You have to take a look at this guy and see if you can identify what the table is counting by, because if it's counting by the same number every time, sometimes that becomes a very natural thing to increment by or to count by. So if we're looking at our table, it's counting by 5 each time. So that tells me I probably want to count by 5. Now I want to back that up with a little bit of thinking. So if I look at my min, I look at my max, I don't want to have to put too many counting marks in between those two. Like I don't want to count by 1 in this case, for example, because I'm going from -5 to 35. Well, that's going to be like 40 tick marks, 40 count marks. That's way too many. So I definitely want to up it. And knowing that my table itself is counting by 5 each time, that means I'm going to increment by 5. Okay? So there's quite a bit of thinking you have to do to tear this table apart to fill in this the mins and the max increments. But it's not too bad once you kind of have a process in place. So again, let's talk about our process. So for the y's, oops, sorry. Okay, so for the y's, again, I'm going to identify my smallest and biggest number. And in this case, since it seems to be patterned, the smallest is on the left, biggest is on the right. And then now I want to kind of pick numbers to scale my graph. Just like with the x's, I could go from 6 to 22, That seems a little bit odd, simply because, again, 6 and 22 would be right at the ends. So it's not a terrible thing to go by. But for me, I always want to go just slightly outside of that, just to make sure I can see all my numbers. So I might be a little more comfortable going, say, from like 4 to like 24, okay? Just outside my range. That way we're able to see all our points, no problem. It's not going to be cut off. We're not going to say necessarily run out of space, right? So now what we're going to count by, well, again, we could count by ones, but if you're looking at 6 to 22, that's going to be like 28 different count marks. That's quite a few. We can back that up by looking to see if there is a pattern in the way it's being counted in our table. And in this particular case, it's always counting by 2. That makes it a very natural increment. Okay? So let's look at another example really quickly over here. Well, there's one right here. Second one on your page. And we're just going to kind of run that same kind of logic again. So again, I'm going to try to locate, so let's go to X. I'm going to locate my smallest number and my biggest number. And again, it would be okay to use those as values. Sometimes, again, it's natural to go just beyond that, but those are okay values to use. Now what I'm going to count by, I could count by ones, but again, I'm looking negative 30 to 50 is going to be 80 marks. That's too much. I'm going to take a look at my table. Okay, I'm going to notice my table is always counting by 10, which means that I'm going to count by 10 here. Also, that only makes it 8 marks instead of 80 because I'm counting 10 at a time. Let's rerun this now for the y's. Smallest and biggest number. Now here we can't just go beginning and end because it's all mixed together. Looks like my smallest number is going to be a negative 6. It actually happens a couple different times. And my biggest number is going to be a 24. Okay? And again, thinking about negative 6, 24, maybe we want to go just beyond that. I'm going to go negative 8. I'm going to go 26. Now figuring out what to count by, it seems to me I'm seeing a lot of even numbers here. 8 to 26, definitely don't want to count by ones. I think 2s might be a little bit more appropriate. So 8 to 26, excuse me, negative 8 to 26. It's still going to be a few marks. I mean, it's not going to be like too many, but that's certainly a kind of a logic you can use in this way to figure out your increment. Just kind of decide, well, is it too much to count by ones? In which case, you can count by a different number. I'm choosing 2s for a couple different reasons. One, I notice they're all even numbers, and 2, counting by 2s won't take me too long to get up to 26. Right? I'm only looking at maybe 15 marks. So let's drop down a bit, and let's take a look at this guy. I can ask you about what graph you need to scale for 2x plus 5 as well. And one way we can do that is to actually produce a table. Like a table is pretty easy to see for the first couple examples. So if you don't have a table, hey, make your own. Now a standard table goes from like negative 10 to 10. So that might be a good place to start with this. So negative 10. I'll probably have to break the table into 2 just because there are so many. 4, 3. Okay, so now I can use this to help me fill this out, but I'm going to do it not just by taking numbers and putting them in. I'm going to tear this equation apart a bit. I know if I have this plus 5, that should occur here. So I'm going to put a 5. And then I know this 2 indicates what I'm increasing my table by each time. Okay, so that should allow me to fill out the table actually pretty quickly. So that should be 7, 9, and of course going backwards I'm losing 2 each time. Okay, and now I can do the analysis like I did before. So let's talk about our x values. Biggest and smallest number, well, I actually picked those out ahead of time. So negative 10 to 10. And if you're looking at my table, counting by ones wasn't too strenuous. It was only 20 marks. And then, if we look at the y values, I got to go from 23 to 15. Again, this is a case where if I want to bump just a little bit outside, so I'm going to go from negative 15 to 25, which will enable me to count by 5s, because again, I'm going to keep everything kind of in terms of 5s. So go ahead and run this video game if you need to. We're going to take the rest of the time, and I'm going to have you guys work on the rest of the examples with the ability to ask questions. So if you're able to do this sheet, you should be able to do the quiz today very well. So that's what I got for you guys. Thank you.